Hello, I am the MadDoctor, and today I'm going to demonstrate the potential of these homemade high voltage capacitors. I will be using two of these microwave oven transformers, or MOTs. I will be using number 2, number 0. The way I have it wired up is 3 will arc with 1 or 0, and 2 will arc with 1 or 0. But 1 or 0 will not arc with each other, and 2 and 3 will not arc with each other. When you wire up a single MOT, it doesn't matter which side you put the hot or the neutral. It will still arc with its own self. But if you want a second MOT to arc with your first one, sometimes you wire it up the same way, where the hot is on the left, neutral on the right, but this one that will arc with this one, the hot is on the right side and neutral is on the left side. It's wired up opposite to the way this one is. So you'll just have to experiment a little bit, figure out, just try hooking them up differently. If they don't arc together, then switch connections. This video isn't really about my power supply, but I am using a hood that I made out of sheet metal, and there is a fan that will go into place right there. The whole time it's plugged up, it will be on. Also, over here I have these light switches that I use to turn on each transformer. 0, 1, 2, 3. And these electrodes over here, 0, 1, 2, 3. And I'm going to be using these two. I made a video showing how to make one of these capacitors, and I will leave a link in the description. But this video will be demonstrating what these capacitors are capable of. The capacitors are connected to transformer 0, the biggest transformer, and this is a piece from an old microwave oven transformer that will be connected to transformer 2, the medium-sized one, and the screwdriver is connected to the other side of only one of the capacitors, so I can show you what only one is capable of. Whenever I turn on transformer 0 alone, this only has a ground charge, and you can see that, I don't even think you can see that tiny arc, but that's what it does to ground. And whenever I turn on transformer 2, there is a significantly larger arc. Now I have both of the capacitors hooked to this screwdriver, so whenever I use only a single transformer, again, there's not much of a difference, just a small arc. But whenever I turn on both of the transformers, there is a lot more potential. As you can see, the arc is longer. I just want to show how comparable these capacitors are to a saline capacitor. This one is very dirty inside, but it still works pretty effectively. This is going to transformer 0. This is the output. So here we go. You can see that the arc is very similar. I know this video isn't about saline capacitors, but I just wanted to throw that in there. Now, I already had 6 of these capacitors made before I made that video showing how to make one of these. So these are 2 extra ones. Now these 2 capacitors are still wired up to transformer 0, but also I put one side of these 6 capacitors in conjunction with transformer 0. On this side I will have 3 of the capacitors hooked up to transformer 2, also running to this piece of metal. The arc is shorter, but it's brighter, louder, and more powerful. Now all 6 of these capacitors are in conjunction. Notice that I can get the arc to be a little bit longer, and it's definitely a lot louder, so it would make an ideal spark gap for a Tesla coil. But that's the potential of these capacitors. Altogether, I would recommend making 8 of them, of course, or experiment using more in different ways, but this is the best way I've found to hook them up. Now for some reason, whenever I use 3 of these without capacitors in between the transformers, I don't know why, but it has a shorter arc when I use 3 over here. So I found that it is better to only use 2 of them, and I would put 6 of them right there. I guess that's it with this video. Thank you for watching. Please like and subscribe.